What if I told you that ancient civilizations tracked celestial bodies with astonishing precision, centuries before modern telescopes? Imagine a time when the stars weren't just distant lights, but a cosmic clock revealing the universe's secrets. This isn't a fairy tale, it's the mind bending story of ancient Indian astronomy. This video will unveil the profound achievements of the sages and scholars who profoundly shaped our understanding of the cosmos. To appreciate the genius of this ancient tradition, consider a modern parallel: the Indian Space Research Organization, ISRO. Known for its groundbreaking yet remarkably cost-effective missions like the Mars Orbiter mission, ISRO embodies a spirit of frugal engineering that is deeply rooted in India's past. The iconic image of India's first rocket being transported on a bicycle in 1963 isn't just a quirky anecdote. It's a modern echo of a civilization that has always excelled at achieving the extraordinary with simple, ingenious means. The story of Indian astronomy, or Khagala Shastra, the science of the cosmos, begins in the Vedas, the ancient scriptures that date back to at least 1500 BCE. For the revered sages, the Rishis, the night sky was both a spiritual canvas and a practical tool. They used celestial observation to create calendars for rituals, track seasons for agriculture, and predict events like eclipses. The night sky was a living mythology. Constellations were not just patterns, but deities and legendary figures, such as the Saptarishi, the seven sages, who are said to guide the cosmos. This spiritual context was built upon a foundation of meticulous empirical observation. In the later Vedic period, the Vedanga Jyotisha emerged as a key text that formalized calendrical astronomy and detailed methods for calculating lunar and solar months, which was a profound leap forward. The classical age of Indian astronomy, starting around the 5th century CE, took this knowledge to an entirely new level. It produced a masterpiece, the Surya Siddhanta. This astronomical treatise, a true manual of astronomy, contains nearly 500 verses and combines rigorous observation with sophisticated mathematics. It is in this text that we find groundbreaking concepts that would challenge the world's understanding of the cosmos. The Surya Siddhanta and other texts from this era asserted that the Earth is a spherical body, a concept that was centuries ahead of its time in many other parts of the world. The precision of their calculations is astonishing. The Surya Siddhanta calculates the length of the sidereal year at 365 days, 6 hours, 12 minutes and 30.36 seconds, a number that is only a few minutes off from the modern value. Aryabhata, another monumental figure of this era, calculated Earth's circumference to be just 0.27% smaller than the modern accepted value, an incredible feat of measurement for an ancient civilization. This precision was not a fluke. It was a result of a monumental mathematical innovation, the invention of trigonometry. The Surya Siddhanta is widely regarded as one of the earliest texts to introduce the sine function, Jyaya, and its related functions like cosine, cojya, and versina, utkramadya, which became the theoretical backbone for astronomical calculations for centuries to come. However, the genius of this era was not without its blind spots. While the Surya Siddhanta's calculations for the size of the Earth and Moon were remarkably accurate, its estimate for the Sun's diameter was wildly off, underestimating it by more than 1,000,000 kilometers. This is a crucial detail that tells us that their genius wasn't in having perfect raw data, but in developing an intricate mathematical framework that could produce astonishingly precise results with the limited observational tools they had available. The intellectual prowess of ancient Indian astronomy was matched by a tradition of ingenious instrument making. Many of these tools were deceptively simple. The most fundamental was the gnomon, or shanku, a vertical rod that casts a shadow. This ubiquitous instrument was used for everything from telling time to determining geographical latitude and tracking the changing seasons. For timekeeping in the dark or on cloudy days, they used various types of water clocks and even sand vessels, which were precursors to the modern hourglass. These instruments weren't just practical tools, they were the basis for more complex ideas, such as Aryabhata's interesting machine that demonstrated the daily rotation of the earth, a revolutionary idea for its time. The culmination of this long tradition of instrument making is best seen in the Jantar Mantar observatories. Built by Maharaja Savai Jai Singh II in the early 18th century, these monumental masonry instruments were designed for naked eye observation. The name itself, a combination of yantra, machine, and mantra, calculation, alludes to their purpose as measurement mechanisms. Instruments like the Samrat Yantra and the Ram Yantra were used to precisely measure the altitude of the sun and celestial coordinates, embodying a fusion of architectural and instrumental innovation. But a closer look reveals a more complex truth. While these observatories were used for astronomical calculations, they also served as powerful symbolic expressions of royal authority and a patron's commitment to rational forecasting and timekeeping. The Jantar Mantar stands as a monumental fusion of political, scientific, and religious needs at the end of the Mughal period. The intellectual tradition of Indian astronomy did not develop in isolation. It was part of a vibrant global network of ideas that crisscrossed the ancient world. Indian scientific thought, with its profound mathematical concepts, became a crucial catalyst for a global scientific revolution. The primary conduit for this knowledge transfer was the Abbasid Caliphate in Baghdad, which in the 8th century CE became the foremost hub of intellectual activity in the Islamic world. Abbasid leaders, recognizing their own limited understanding of astronomy and mathematics, actively sought out knowledge from other civilizations. This intellectual exchange was sparked by the arrival of Indian scholars in Baghdad. The Caliph al-Mansur was so intrigued by the Indian systems that he commissioned the translation of key Sanskrit astronomical texts, including Brahmagupta's Brahmasfuta Siddhanta, into Arabic. These translations, known as Sindhind and Arkand, were monumental. They introduced the Islamic world to a systematic and scientific approach to astronomy, with one scholar noting that the Arabs learned from Brahmagupta before they learned from Ptolemy. The transmission of this knowledge was one of the most significant contributions to the world, bringing with it Indian numerals and the concept of zero. The decimal place value system, far more efficient than the Roman or Greek systems, was transmitted to the Islamic world through these astronomical translations. Scholars like Al-Khwarizmi enthusiastically adopted this system, playing a pivotal role in its global dissemination and laying the foundation for modern arithmetic. Similarly, Indian trigonometric functions such as Ja and Kotija were translated and became the theoretical backbone of Islamic and later European astronomy for centuries. The legacy of ancient Indian astronomy is not a relic of the past. It is a living tradition that continues to inform and inspire. The precise calculations laid out in texts like the Surya Siddhanta still guide the traditional calendars and religious practices of India today. This profound intellectual heritage has a direct thematic connection to the modern Indian space program. The same spirit of ingenuity and resourcefulness that allowed ancient astronomers to measure the heavens with the gnomon echoes in ISRO's ethos of frugal engineering. The presence of prominent women scientists in key leadership roles on missions like the Mars Orbiter mission also reflects a progressive and inspiring culture that is a modern continuation of this ancient intellectual journey. The story of Indian astronomy is a testament to the power of intellectual rigor and ingenuity. It is a story of sages and scholars who, with rudimentary tools, measured the heavens, calculated immense cycles of time, and laid the mathematical groundwork for trigonometry and modern numerals. The journey of this knowledge, from the Vedic hymns to the halls of Baghdad and across the seas to Europe, demonstrates that science is a shared, global endeavor built on a foundation of cross-cultural dialogue and critical inquiry. This enduring legacy, from the monumental observatories of the past to the satellite launches of the present, embodies a persistent quest for cosmic understanding that continues to resonate with humanity's shared intellectual heritage. If you enjoyed this journey through ancient Indian astronomy, be sure to subscribe to the Saptasindhu Archives for more stories that decode the secrets of the past. Let us know in the comments below what other forgotten chapters of history we should explore next.